Aloha everyone, my name is Mia Fong and I am a civil engineering student at the University of Hawaii in Manoa, and over the summer I have been doing research with my lab mates.
Aloha, I am Brenton Sasaoka. I am a sophomore majoring in civil engineering.
And my name is Seth Colburn and I am a junior majoring in civil engineering.
So for the past 10 weeks under our research advisor, Dr. Albert Kim, we have been working to forecast the COVID-19 spread in the Hawaii state counties. Next slide, please.
So as we all know, COVID-19 has become a serious issue this year in 2020, and United States being the country with the highest cases of corona cases in the world, it kind of begs the question of how does it affect us living in Hawaii. Next slide. So if you look at the table to the left, as of August 11, 2020, these are the information of total cases and total deaths of counties in Hawaii as well as the statewide. Honolulu being the county with the most amount of cases and deaths with a total of 3,361 cases and 27 deaths. And if you look to the right of that table, we also have predictions that for August 31st, and Honolulu being 4,050, Maui 196, Hawaii 169, Kauai 50, and statewide altogether, it comes up to a total of 4,465. So because our data is changing every day and cases changing every single day, if you want our updated predictions as of today, you would just have to go to our website, and it shows the images on the right front page of the website. That's where you can find the latest information of our predictions. Next slide. So I just said predictions. So how are we finding out predictions? If you look to the cumulative confirmed cases statewide on the graph on the left, the way that the graph grows is that it slowly climbs up before coming to a plateau and then rising again. We as a group, we noticed that it resembled a hyperbolic tangent function, which Mia will go into more description of later on in the presentation. But using this hyperbolic tangent function, that is how we did the basis of our research and predicting future cases and trend lines. Next slide. So why are we focusing on this? Why are we doing our research on this? At the end of the day, we are doing this because unfortunately we lack the data analysis in Hawaii. There isn't enough data, and the data that there are that's being used, it's not being used to predict the amount of cases that we could see in the near future. And this is important to us because it kind of keeps us aware of what we're doing. It gives us like a perspective of if we don't stop like going to parties and everything, then cases are only to climb. So it's kind of just to make everyone aware and see that if we don't stop what we're doing, then it'll only climb from there. Next slide. So for our project goals, as I said, we are currently making predictions of future trend lines in corona cases across all 4 counties as well as statewide. So how are we doing this? We're taking daily analysis. So we are getting daily cumulative data, and we're using that hyperbolic tangent function, which I've said in the previous slide, to change its parameters to make it best fit our current data. And we are also publishing our findings to the general public so everyone is aware of our research and they have a better understanding. So the way that we're publishing our findings is we're creating websites, which I said, hicovid.net. We are planning on creating a preprint, and we are working with other collaborators in other ways, getting onto Hawaii News Now as like recently, and just showing our research to the general public any way we can. Next slide. Okay. And in order to do all of these things that I've just said, what we're focusing on is analyzing these 4 primary types of data by county, and it is the cumulative confirmed cases and deaths, as well as the new daily cases and deaths. Next slide.
So now we're going to go into a brief overview of our methodology and how we got to the data analysis and prediction point. So the very first thing we had to do was determine what function we would be utilizing for modeling. So in those graphs that you saw before that Seth talked about for the statewide cumulative confirmed cases, as you saw, there was an initial increase and then a slower increase followed by a plateau. These 2 portions resembled exponential growth and decay respectively. But we found that if we were to use these 2 functions for fitting, it would be twice as much work, and we'd have to find the point where it transitions from growth to decay, which would cause more errors in our predictions. And so we took a step back and looked at the functions and noticed that they had these S-shaped or sigmoid curves and chose to utilize hyperbolic tangent. So on the right, we have a graph that depicts the different parameters that we have for our equation. So once we determined our function, we had to figure out what parameters we would need to give the equation to be able to best fit it. So at the top, we have this dashed blue line, which represents our Y maximum. So this is the maximum number of cumulative confirmed cases where we begin to have that plateau. Next is how fast the values are changing, our slope in green. And then lastly, when did it start, or where is our shift to horizontally, and that is our x naught, which is the midpoint for that wave. Once we determined what parameters we would be using for best fitting, we moved on to the actual fitting process. So we used a multivariable error minimization process. Using the solver tool in Microsoft Excel, we selected these parameters, these 3 parameters that we just talked about, and set it so that it would minimize our error, and it would do the calculations for us. Next slide, please. So in the left, in red, we have the original function for tangent h before we enter our parameters and begin manipulating it. So its initial characteristics are arranged from -1 to 1, which we know we want to shift vertically, so we only have positive values as we only deal with positive cases. And then next we have a domain from -infinity to positive infinity, but we want to shift this to the right because we want to make sure that that initial increase begins in the positive side because we have a positive number of days for our cases. Next. So now in green you can see a slightly modified curve. It's been shifted vertically with that +1, and then it's been halved in height with that divided by 2. So this accomplishes our first goal of having a positive range. Next, please. And this last graph in blue includes all of the parameters that we've talked about and shows you what our best fit curve would look like, more so when it's actually fitted to data. So we have our hyperbolic tangent multiplied by 5, or our Y maximum. And then in the parentheses, we have the x minus 10, our horizontal shift, which is why you can see our midpoint for the curve is at 10. The +5 for our Y max, and then divided by 2 once again. Next. And here we have the general equation for our best fit curve and what we actually put into Excel.